good evening, everyone. I would like to thank the organizers for inviting me and also everyone for attending this presentation. I came with a topic that is very student-oriented, so it might be of interest for everyone that is a student or has ever been a student. And it's also about data analytics, so it's related to what probably the previous talks have touched. And let me start a little bit with a story. Isn't it that it's very important for everyone what you want to become when you're grown up? No? So this is something that you think about, some more, some less. It's a personality thing as well, of course. This is where we're trying to help people. And what we do is, well, we look at the situation first, and this is a little bit US oriented. And the numbers here are that there's about 20 million students in the US that enroll every year. For a country of that size, of course that makes sense, but I guess in Greece there's also a significant number of people that have to decide what major will you enroll in. And almost even worse, because that's a difficult decision though if you look at all your options. So in the US there is about 2,000 majors that you can choose from. Of course there's a lot of niche solutions and overlaps, but 2,000 is a big number. And then there is 44,000 accredited programs. So which is the program that you're actually going into, and 6,000 colleges. Now you have a little bit of flexibility, you might want to go different places. So if you can afford it, this is a very difficult problem. In the US it is that you pay for your education a lot. That means that there's also a significant economical factor here that has to be considered. So you want these people to make good decisions because they spend money, and that's part of your economical system. There's three phases that we see. We see before making the decision, you're maybe in high school or some school that brings you to university, what should I actually do? Once you started your studies at university, you ask yourself, is this really what I want to do? Is this the right thing for you? And then once you start working, I should have never started this program. And you can always go back, of course, but that is a little bit of a loss in your career, I would say. Nothing wrong with that, but not everybody might want that. So we know that in each of these phases there's issues, and these issues are dramatic. So 66% of students feel just overwhelmed. If you ask them, if you look at all these options, how does that feel? I don't know what to do, is what more than half of them say. And more than 50%, they change at least once. I didn't know these numbers, they're huge. So this happens silently. Number one, because people often don't make a big deal out of it, and number two also, it might be easy, maybe you change from mechanical engineering to maybe industrial engineering is an easy switch, so it's not a big deal, but it might cost you a little bit in your career. The worst thing is that, and this is something that I know from the US, 44% of the people, they regret having chosen a certain major. And here it's getting kind of late. So when you're going towards retirement, it's not that you can restart, but you can help your children. What do you want to tell them? To use our system, right? So we come up with an approach that might support people and maybe bring down these numbers a little bit. Look here on the left, all the courses. This is just an example. Manufacturing processes, material removal. Of course, before making that decision, you could go into the data and do a thorough analysis of all of that. Do you understand? Well documented in these program descriptions. So, we have a method, and that method does the following. It first looks at program data, and program data for us means course descriptions. So if you have, for example, a management science undergraduate program, it comes with a curriculum that has mandatory courses and elective ones, and all these have short descriptions typically. They are more explanatory or less. That depends a little bit on culture, on program, also on on all kinds of factors, but this data is available and it's typically publicly available, right? So we get all this data in an automated fashion and apply a diagnose. This is how you would call it in an analytics world, and we do topic modeling. Topic modeling is that we try to extract topics. What is a topic? Exactly what you think of a topic. A topic is certain fields, subfields that somehow belong together. So the topic today here is about a decision support system for course selection, and the technique behind this is machine learning. So So it's actually translating language data into numerical data, and then basically a clustering mechanism that sees what are subtopics that we could put together as one topic. Once having done this, these topics are presented to the student. And how do you interface to the humans? Well, one way to do this is you create word clouds. This for us seemed very intuitive. So you have a word cloud for every topic. Here you see 6 word clouds, and every word cloud represents a topic. So there's different words that tell you something. So you can interpret this and see this as a topic. So we see a bunch of topics in this huge program data database, and we present it to the students or to the future students. And then the student or the decision maker has to indicate, hey, what's interesting for me? What are the topics where I can see myself? And this is not reading complex stuff. These are keywords, right? Milk, not joking, in an agricultural program. For example, analytics, is that something that in principle interests you? So you combine your interests by selecting these topics, and then let us do the job. We're going to come up with a short list of programs that are most relevant for you. And we rank them, meaning that you should look at them from the top to the bottom. There's parameters in here, how many do we suggest? Now, this is not telling you what you should do. This is helping you finding interesting programs that match your personal interests. Then you do the thorough analysis. That is unavoidable. Then you talk to your parents, you talk to maybe the people that support you at the university. This is a step that you still need to do, but you have a good starting point. And why is this a good starting point? I'm trying to justify. We implemented it. So we created a prototype of this system, and it uses at this one university the program data, the course data, and the descriptions. This is what I started with. And if you look at how this looks like, it's this is only programs and courses at a mid-sized university, meaning that the colored dots here are programs, the black dots are courses, and there's a connection between a course and a program if this course can be taken as a mandatory course or as an elective in this program. So, of course, that is not a one-to-one correspondence. And if you lay that out nicely, this took me a while to create this picture, then it looks still like this. This is not where you say, oh, obviously not that. It's still very complex, what I'm trying to say. This is also very interesting from a university management perspective. Why? Well, because you understand a little bit about the structure of the knowledge that you're actually teaching here in this university, and how the programs now shape that. There's some programs that are a little bit weird or isolated. Just to mention a few, music is a little bit strange because there's not many programs that require you to take music classes, but music as a program has all music classes. Military is also a little bit strange because it's very isolated. Strange means isolated. And then there's some that are very central. And you could think about very generic courses, or maybe general education courses that have to be taken in physics, chemistry, whatever, starting courses, introductory courses. They're connected to all kinds of programs. You really need them for engineering degrees. So we did this. Numbers are here. 84 programs, 2,500 courses, and 6,000 connections. So you're already dealing with huge data if you look at it from an abstract point of view. We didn't even see the course description, but there's one for every course. We created 30 word clouds. 30 is a parameter for this system, right? That's something that you have to somehow fine-tune, know what's the parameter settings that you want to use. Here you have just an example, 12 of them. Let us look at them, because it's important that you see what I'm talking about. And I looked at them many times, and I'm going to tell you what the users think, and also then what I think of them. For example, accounting, economic, financial, income market. Does that ring a bell somehow? At a business school, this is something that people should be familiar with, at least after graduation. Child, teaching, title, scientific, camping. Okay, now so it gets a little bit emotional. So everybody will interpret it a different way, but if you don't like that one, skip it. So how many can you give me? It's a parameter. I could tell you have to give me 3. That's not what we did. We kept it open. I think we said give us up to 5, up to 7, because otherwise it's getting too much. Now, if you give us all of them, all the programs will be recommended. No, that doesn't make sense. If you select a few, example these ones here. So this is, I'm going through one user here with you, pretending that's me. I selected model regression statistics, factorial probability distribution, right? You wouldn't even read all the words, actually. You would read the ones that you want to read, the ones that you can connect with. Government, field innovation, business, network systems, computer distributed packaging, printing, construction, team management process. I think this could match a personality, could. You know? I would say that is a technology-oriented, business-minded person. It's just my interpretation. No? Let's see what we recommend for this person. So this is the short list, and the short list says bioinformatics. Bioinformatics, I have to go back with bio, comes from industrial engineering, management, human resources, manufacturing engineering, industrial technology, computer science. How did we come up with this list? Basically, we statistically backtrack, meaning that all these keywords in these topics come from a course description, and the course belongs to a program. So we count, okay, in every program, how many keywords of your selection can be found in there. So there's programs that have less courses, so we need to also normalize that. So we have program interest score and a relative program interest score, which will then tell you, okay, for a small program, of course you're not going to see these keywords that often because it just has less courses. So you have to somehow normalize it by the size of the program. Well, it doesn't matter, I think the numbers look good. Computer science is a little bit further away. For this year, there's a lot of discussion going on about explainable AI. I can give you, I'm not going to show you, but just in a sentence, I can give you the explanation where these scores come from. I can tell you how much every cluster, every topic contributed for every program. So if you're interested in, you know, how did I come up with this one? And I can also tell you why not. I can tell you below which ones are the programs that, you know, for a certain reason were really not interesting for you in selection. And then you could turn this in an iterative process. And you could, as a user, say, am I really interested in that cluster where there's milk on it, no milk and dairy? Maybe not. What if I take it out? Right? Experiment a little bit. Find out what your actual interest is. No? So you could go for it in an iterative fashion. We evaluated this. I think it was 60 or 70 students, and we asked them, does one or more of the recommended programs match your interest? And they all said, yeah, there's something interesting in there. That's a little bit the baseline that we wanted to see. But then we also asked, is there a program in there that you didn't consider at all? And that's interesting. And a lot of them said, wow, I didn't know, and this is what we wanted a little bit. We wanted them to not be informed about programs that could be relevant. Now, you don't have to choose any of these programs, but you want to consider them. We also asked if they find this useful, and people said yes. Was it easy to use to select these word clouds? You know, could you work with that? And people said yes. And were they meaningful? And even here, people said yes. I could see something in there. You know? It's not that it didn't seem random or making not sense. And would you be using this in addition to sources that are out there? People agreed. So this for us was a little bit the support that we wanted. We found this useful based on the feedback that we got. There's a couple of features. Recommended systems need to be evaluated. And we did a thorough evaluation, also using literature concepts and what people do in the industry. But for us, most important is fairness. What does fairness mean? Fairness means if I run a program and mine gets never recommended, that's not fair, right? So what we had to do is we had to try all combinations of selections and see how often all the programs got recommended. And this depends on the parameters. And we found out that, except for one program, can't remember the name, all of them appeared regularly, right? And that means fair for us. But it depends on the parameterization. The system is efficient. It works in real time. Now it takes a second. Immediately gives you an answer. That's nice. So you could implement it in an app or whatever. Also, everything's open source. All these packages that we use, nothing is written by us. The serendipity is something that I touched before. Serendipity means that, surprisingly, you're getting recommended something that you wouldn't have considered without hearing about it. So let me summarize a little bit our contribution here in this work. It's a new approach for program selection. The ones that are out there are, number one, not really applied. So this is a very application-oriented system, and at the same time it uses machine learning to recommend. That's something that people didn't do in the past. We have these, I think, nice representations of knowledge in higher education. That's something also, perspective that maybe is new. Our prototype that we have is out there, right? So if you contact here my co-author or my student, he will be happy to go through that with you. We validated it using a quantitative study, so we really asked humans if they would use it and how they like it. And that's beyond computationally evaluating fairness and so forth. What can you do now from here? Of course, as we already heard, you can try to sell this, or you can try to make it available. Apply not only for one university, for multiple universities. Why not? So you have to create a bigger system. How far can you go? That's a topic by itself. Why not including more information, not only course descriptions, but the syllabi? So very often you get a description of what the actual instructor then uses in the course, or how he structures that course. Throw that in there. It's machine learning, it's just more data. Why not the slides? Maybe they're publicly available. Maybe the titles of the textbooks, whatever. Feed it with more data and see what comes out of that. Maybe you get a higher accuracy when representing the topics that can be found in there. Why don't you include study abroad programs, certificates, minors, and other parts of the curriculum, something that is not a traditional course? You can totally do that. You could even integrate taking a semester off, whatever you want. Try something that goes beyond the data that is out there. What do we want to do? We want to make everybody happy. This is a non-profit project. We do it for the students. We also do it for the programs, because something that came us later is that if program managers experiment with this program, they might rethink how they write their descriptions, what data they make available, and also how they shape their program. I want to be ranked first. Right? So there is a little bit a game going on here. It's the student, the client, and the person that offers the service, the university, the program managers. If you're interested in that, you could check out, we wrote a paper that was just published here in Data Mining and Knowledge Discovery. It has a couple more details. There's also a free version available, a preprint here on our side. The link is down here. Of course, you can always contact me or talk to me. I'll be happy to maybe connect you to my student or also answer you all kinds of questions. Thank you very much for your attention. If there is any questions.
Are there any questions?
You have a microphone.
Okay, hello. I would like to point out some ideas for future opportunities. Like I understand the concept of navigating through the programs of each university and then transforming them into word clouds. But I believe that it would be more useful if there was like each student takes a test, completing their hobbies, their interests, and then the results of these tests are used in order to combine the results of the word cloud thing.
Yeah, I totally agree. That makes sense. So, in fact, in a more detailed version of this, what we suggest but haven't implemented is additional filters and preferences that you can apply. That you exclude certain things that you know that you don't want to see. This gives you more flexibility, but could also be interpreted as a technical part of it. Practically makes total sense. Thank you. Any other questions or ideas? And maybe one last thing, so we're taking this to a different level. What do we do? The idea itself is kind of generic. We're doing it for conferences. This is a conference. Imagine a huge conference with a lot of parallel sessions, one of these medical meetings, and you don't know where to go, but you have certain interests. What do? You study that conference book that has 100,000 different presentations, you don't know anything? similar situation, right? So think about it. There's many situations where you can also apply this. There might be a few where you can actually make money with. So, yeah. Thanks again.